Solids. Some properties of solids. There are a great many kinds of solids we come across every day, many more than for liquids or gases. There are dozens of ways we can describe solids by referring to what we call physical properties. I've chosen 4 of them to focus on in this video: shape, volume, compressibility, and fluidity. I mentioned there are dozens, so here are a few more. You may already know some of them, like odor, luster, color, hardness, or density. The others you'll come to learn about in future years. Now back to the first 4. I'll return to compressibility and fluidity after I do shape and volume. Shape and volume are described in this way in a textbook. The shape of solids is definite. That is, it has a fixed or unchanging shape, and volume is also definite. It has a fixed volume. In a similar manner, here's a definition found online. Solids have both a fixed volume and a fixed shape. Now this is fine for solids like gold or glass or wood. These solids are rigid, as long as we assume that any force we apply on them is not enough to damage the material. But what about solids like these 3? Plastic, paper, clothing. These materials require very little force to change their shape. So this is a problem unless we broaden our classification of solids. We'll do that by calling the first group rigid solids, and the second group non-rigid solids, also known as soft solids. Let's set up this diagram and show solids divided into rigid and soft. Let's indicate shape and volume here. We know that shape is definite or fixed for rigid solids, and volume is also definite or fixed. But how would you describe shape and volume for soft solids? I would say they are both variable, because a little squeeze can change both their shape and volume. Think of a sponge, for example. Now let's look at the other 2 properties, compressibility and fluidity. For compressibility, we know that rigid solids are not compressible, so we write incompressible. If you try to compress them too much, you may break them or cause some damage. But what about soft solids? Well, they're easily compressible. Now for fluidity. This property refers to being able to flow like water. Gases can also flow, even though they're hard to see. We can see that rigid solids are not fluid. They cannot flow. But what about soft solids? Well, they can't flow either. So now looking at all this, what property clearly distinguishes solids from liquids and gases? Fluidity. So if there's any question about whether a substance should be classified as solid or not, just ask yourself, will it flow? Is it a fluid? Now, here's a familiar substance, Jell-O. And here's another, custard. Solids like these are often called semisolids, as they fit in between solids and liquids. We can also include creams, ointments, and gels. So let's add this last category, semisolid, and compare properties. The shape of these semisolids is easily changed, so we'll say variable. Volume, however, is trickier. If you squeeze Jell-O, it will change shape, but the total volume will still be the same. The Jell-O was just squeezed out in some other direction. So we'll put definite here for volume. These materials are compressible, and they do not flow, not fluid. I chose shape and volume because these are the 2 most common properties used to describe solids. I chose compressibility because it's a good property to distinguish rigid solids from soft and semi-solid solids. And fluidity was chosen because it's the best property to easily distinguish solids from liquids and gases. Finally, what about flowing sand, like this? Is this a case where solid flows? Here's another example with an hourglass. At first glance, it looks like it, but we need to consider that sand is made of individual sand grains like this, which are simply falling down. But taken all together, it gives the appearance of fluidity, but the solid components of sand, these grains, are themselves rigid. This ends the introduction to some properties of solids.